Hello, Algebra 2. So what I have done is I'm breaking these videos into the no calc and a different video for the calculator portion so that one video is not so long. So we're going to start in on doing the special triangles first. So you should not have a calculator, you should know your ratios. So if I have a 45-45, what I like to do is write my ratios on the inside. So it's your x rad 2. And then you can take what they gave you. So C is 8 rad 6. And we can make an equation out of that. 8 rad 6 equals x rad 2. So I want to solve for x. So what I can do is I can divide both sides by rad 2. That means that x is going to equal 8 rad 3 because radicals can talk to radicals. And what we want is side A, which is x, so that's our answer, 8 rad 3. Okay, then the next one they give us is A is 24. So if A is 24 and you want side C, it's a matter of substitution. So we know that our x value is 24 times rad 2, and in this case, that's going to be our answer, 24 rad 2. Now when we get to our 30, 60, 90, luckily this one's a little more in keeping with the size of the angles. Opposite the 30 is the x, opposite the 60 is the x rad 3, and your hypotenuse, which is longest, gets the 2x. So when we go to find our ratios, it's telling us E is going to be 10 rad 3, that's my x side, and they want us to find D. So what you're going to do is you're going to take 10 rad 3, that's your x, and when you substitute it in, you still have to multiply by rad 3. The two of these together becomes rad 9, which simplifies to 3. So we end up with 10 times 3, which is 30. And again, silly me, well, you have a little built-in check here. I didn't realize I did this. If I put an integer on the side that has rad 3, the way you would solve it, well, in this case, it kind of went backwards, but we're just going to do it anyway. I would let 30 equal x rad 3, and I have to, again, solve for x. So I would divide both sides by rad 3, and remember, we can't have a radical in the denominator, so we multiply top and bottom. So this bottom becomes 3, and so again, 3 goes into 30 10 times, so we have that x is 10 rad 3. But let's see what they wanted. They wanted side f. So f is 2 times my x value, which is 10 rad 3. So this is going to be 20 rad 3. So once again, on your actual, on the hard copy, I forgot to multiply by 2, so that is a mistake. All right. Now we go down to where you can use your unit circle, but you have to know how to use your unit circle. So what I've done here, I can't draw the whole unit circle here, but I've shown you this is the first quadrant, because remember, everything else is the same except positive and negative. So let's talk about how we would do it, because it's really about knowing your reference angles. Cosine of a negative 150, that would normally put you right here as a positive angle. That would be the same thing as finding the cosine of 210. The way you can find that is just go 360 minus 150. That'll give you 210. That is a 30-degree reference angle. So if we look at our 30 degrees, remember cosine is the x value. So this would be rad 3 over 2. And in the third quadrant, your x value is negative. Secant is going to be 1 over x, the reciprocal of the x value, because it's the reciprocal of cosine. So pi over 3 is 60 degrees as well. So we go to our 60 degrees. The x value is 1/2, so the reciprocal of 1/2 is 2. Then we go to tangent. Tangent 135 is basically a 45-degree angle, so the reference angle would be the same. And notice that this goes with your isosceles triangle, so opposite and adjacent are the same. So that means you're going to simplify the y over the x is going to simplify to 1. But in the second quadrant, where x and y are different signs, this will simplify to a -1. Then we have cosecant of 60 degrees. So this is going to be 1 over the y value. So we look at our 60 degrees, the y value is rad 3 over 2. So on this one, if I take the reciprocal, I get 2 over rad 3. I do have to rationalize that. The denominator becomes 3, and I have 2 rad 3 over 3. And that's your final answer. It's ugly, but it is what it is. Cotangent. So cotangent is going to be the reciprocal of tangent. So this is going to be x over y. At 180, your unit circle is -1, 0. So the x value is a -1, the y value is 0. You can't have 0 in the denominator, so that one is undefined. You could either use that symbol, or you can actually say undefined. Sine of -2 pi over 3. So realize this is a reference angle of 60 degrees. So the sine at 60 is going to be a rad 3 over 2. We just need to know what quadrant does -2 pi over 3 land in. So -2 pi over 3 is the same thing as -120, which would land me in the third quadrant where both x and y are negative. Then we have the cotangent of 60. The cotangent of 60 is going to be, again, x over y. So if we look at our 60 degrees, the x over the y, you can ignore the denominators because they're going to cancel each other out. I don't have to include the 2, the 1/2, the rad 3 over 2. Just pull off the numerators, the denominators will cancel. However, I do have to rationalize this. So rad 3 over rad 3, where the denominator becomes 3, and your answer is a positive rad 3 over 3 because that's in the first quadrant. And then our last one, cosine 420. So that's as if you go around the circle one time, and what's left over is another 60 degrees. So cosine of 60 is 1/2. All right? So you will be able to use your projects, and that way you can, if you've got everything correct, you can just read off of your unit circle there. Okay? Now let's start in on some graphing. All right, so when we are doing our graphing, I am also going to be checking that you know how to identify the parts. So our vertical translation, remember in general it's C plus A cosine or sine B x minus D. And I kind of have the list in the order that you would then see it here. So C, which is our new sinusoidal axis, for this one will be 2. The amplitude is a positive 3, but this actual graph will be reflected because of this negative. So I like to give, don't call the amplitude -3. It's still positive, but it will be a reflection. The period, since we are in degrees, I'm going to go 360 divided by 2. Tells me I can finish in 180 degrees, one cycle. But I'm going to start that cycle at 30 degrees. Which means I'm going to end, I'm going to add these to figure out when I'll end. I would be ending at 210. So then we go to plot this. So I'm going to start here at 30. I'm going to end at 210. If I add those together, that's 240. Half of that is going to be 120. If I add 120, 130, that's 150. and half of 150 is 75. So notice each segment is a distance of 45 degrees. So if I add 45 to 120, that puts me at 165. Or you can take the average of 120 and 210. Okay, so now we need to do the y-axis. My sinusoidal is going to now be here at 2. So I'm going to put my little dotted line in there. My amplitude is 3, so I'm going to go up to 5. That'll be the high point. And I'm going to go down to a -1. I'm going to kind of put it below my numbers. And now we are going to do the graph. So it is a cosine graph. Normally cosine starts high, but because it's reflected, it's going to start low. Then does the sinusoidal, then goes high, sinusoidal, then goes low. And then we just draw the graph. And that's it. Looks like a big mustache. Okay, let's do the sine graph. So sine, our vertical translation is -2. Our amplitude is 4. There's no reflection there. We have a pi over 2 as our b, so that means we're going to label everything potentially as pi. So 2 pi divided by pi over 2. If you were to invert and multiply, that's going to be like 2 over pi. So notice the pi's cancel, and your period is also going to then be 4. You're going to start at 1, which means we're going to end at the sum of those two, which is 5. So kind of nice, all the pi's go away. So we start at 1, we end at 5, 3 is a halfway, 2 is a halfway, 4 is a halfway, so that's a friendly label. So my vertical translation's down here at a -2, but my amplitude is 4, so I'm going to go up to 2 and down to a -6, and kind of give myself some dots, and then we're going to draw the graph. So it's a sine graph, so sine starts on the sinusoidal, which is right here at a -2, then it's going to go high because it's not reflected, sinusoidal, low, sinusoidal, and then we can connect the dots. Voila. Okay? So, then on to the next. So here we have 2 of our other 4 graphs. So if you can remember how to do these, you should be fine with either the cotangent or secant. So tangent, just to remind you, if you don't remember your parent function, you can quickly, plus you'll have your unit circle, so you can just look at it. And remember how we got our asymptotes was looking at where y over x is undefined. So when I do y over x, I'm going to be undefined at the 90 and the 270, and I'm 0 at the origin and 180. So we tend to go backwards first on these. So I'm going to go back here to -pi over 2, and I really don't care whether you do it. I'm going to do it both ways so you can see it doesn't matter. I'm going to write this also as -90. Choose which one you're most comfortable with. I really don't care. So this would be pi over 2, or if you prefer, 90 degrees. Now, also remember positive, negative, positive, negative. That's how the sign goes for a tangent graph. So if we're positive in the first quadrant, we're going to pass through here. We're negative in that fourth quadrant, because this is the fourth quadrant, this is the first quadrant. So the graph comes up, goes through the origin, and then is positive in the y-axis. Okay, that's your parent function. What we just graphed was y equals tangent x. So what we have to look at is how does this 3 affect the graph? It says I can do, because the normal period for a for a tangent is pi, or 90 degrees. So that means we can do 3 cycles in 90 degrees. Well, 3 cycles, that means my graph is going to get smushed. It's actually going to be smaller in terms of the scale if I'm only doing 1 cycle. So the way you do that is you are going to multiply the x values by the reciprocal, by 1 over b. So I'm going to multiply by 1/3. So if I multiply this by 1/3, this becomes negative 30, and this becomes 30, which makes sense. That's a distance of 60 degrees. I can multiply this by 1/30, so it's negative pi over 6, and this, multiplying by 1/3, becomes pi over 6. Now, it would be nice if you guys then actually erase your old answer, but I just want you to see the process here, okay? And you please do not give me both radians and degrees. Choose which one you're comfortable with, but I want to do both so anyone that's comfortable with the other can see. All right, notice I didn't even change the graph. I just changed the label, but it's important that you multiply by the reciprocal because remember, horizontal always works the opposite. Okay, so now we have our cosecant, which remember is the reciprocal of your sine graph. So what we're going to actually do is label this as if it were a sine graph. So my amplitude is going to be 2 because I have no other phase shift to negative 2 and 1/3. Now at this point you can choose whether you want to do pi or radians. I don't care. I'm going to do this one in degrees. So 360 divided by 1/3 means you're going to multiply 360 by 3, which is 1080. So I'm going to start at 0. I'm going to end at 1080. Half of that is 540. Half of that is 270. And if I average those two, it's going to be 810. And so I'm going to put in the dots for a sine graph, but I'm not actually going to draw the sine graph. So sine starts on the sinusoidal, goes high, sinusoidal, low, sinusoidal. What we do with that, so now we're going to draw actually our cosecant graph. Wherever you touch your sinusoidal, that's going to be an asymptote. So we're going to have 3 asymptotes. And then off of the high, we're going to draw a parabola because that's going to be the reciprocal of our sine, and a parabola going down. And that would be your graph. Okay? I hope that is helpful.